Hey class, tonight we'll be talking about tangent lines. We'll be doing 3 examples, 3 tries. Hope everyone's social distancing and staying safe. So here we go. Tangent lines. Okay. And what is a tangent line? Let's take a look at what a tangent line is. So what exactly is a tangent line? Well, let's take a look. A line that touches a circle at one point. Now, what's significant about this? Here's a tangent line, and it touches a circle at this point here. It's called the tangent point. And what's significant about this is that there's a theorem called the tangent to radius theorem, and it says that if a line is a tangent, then it is perpendicular to the radius. And what is the radius? If you guys remember, the radius is from the center of the circle to the tangent point. So it's basically the distance halfway across of a circle. Okay? And what's important is that the radius and the tangent line touch each other at 90 degrees. So knowing this, let's apply this theorem. Let's examine example number 1. Find the measure of the unknown angle given that LM and NM are tangent lines. Well, what's significant about that? If LM is a tangent line and NM is a tangent line, then guess what? Angle L and angle N are 90 degrees. So let's go ahead and draw that in. So angle L is 90 degrees, angle N is 90 degrees. Now why do we know that? Because we just learned that tangent lines are 90 degrees. And we're just told that those are tangent lines. Okay. Now, given that tangent lines are 90 degrees, how do we find the measure of angle X? Well, if you guys remember, what is the inside of a quadrilateral? So, if you guys remember from our last studies, the sum of the interior of a quadrilateral is 360 degrees. So, we're going to create a formula to solve it. So we say x plus 90 plus 90 plus 126 is 360 degrees. Combine like terms, 90 plus 126, that's going to give us 306. Now we go ahead and solve it. And minus 306, cancel it out. And x equals 54 degrees. And there you go. That's how you do example 1. Now you guys can try number 1 on your own. Again, you can pause the video while you try it, or if you understand it, go ahead and move on to the next one. So let's go ahead and solve this problem. Hopefully you've had time to do it. So here we know, given that RS is a tangent and TS is a tangent, then we know that R is 90 and we know that T is 90. So if we know that, then guess what? We can create an equation. So we can say x plus 90 plus 90 plus 144 equals 360. Combine like terms. That's x plus 324 equals 360 minus 324 minus 324. And we find out that x equals 36 degrees. And there you go. If you got that right, good for you. Okay, let's move on to the next one. Example 2. Here, notice what do we have? Instead, we have a triangle that's created rather than a quadrilateral. And again, it's the same thing. They tell us that FE is a tangent line. So if FE is a tangent line, then that must mean that angle F is 90 degrees. Now in a triangle, if you guys remember, what's the interior measure of a triangle? That's right, 180 degrees. So we can create an equation that says x plus 90 plus 43 equals 180. Now let's go ahead and combine like terms. X plus 133 equals 180, minus 133 minus 133, and you find that x equals 47 degrees. And that's the measure of angle E, the unknown angle. If you understand that, go ahead and try number 2 on your own. Here we go. Again, hope you guys had a chance to do number 2. Here we go. It says tangent. It says WV is a tangent line. So if WV is a tangent line, guess what? W is 90 degrees. So how do we find angle X? Again, create an equation. X plus 90 plus 65 equals 180. X plus 155 equals 180. Minus 155 minus 155. Cancel it out. And X equals 25 degrees. If you got that right, good for you. And the last application that we are on is example 3 and the last example. Here we go. This will be the last part of the lesson. So determine whether there is a tangent shown. Well, again, in order to create a 90-degree angle, then it must be a right triangle. So in order to be a right triangle, it must follow the Pythagorean theorem. So if it does not follow the Pythagorean theorem, then it's not a right triangle. And if it's not a right triangle, then it's not a tangent line. So that's how we determine whether there is a tangent line or not. So let's see. We're given 7, 24, and 25. Again, the Pythagorean theorem, let me remind you, is a squared plus b squared equals c squared. So let's go ahead and do that. A squared is 7 squared plus 24 squared equals 25 squared. Okay, substitute the numbers in there. Remember, A stands for the short leg, B stands for the longer leg, and remember, C stands for the hypotenuse, the longest side. So let's go ahead and solve it. 7 squared is 49. 24 squared is 576. And 25 squared is 625. Well, let's see. Is 49 plus 576 going to equal 625? Let's see. 625 equals 625. So guess what? This follows the Pythagorean theorem. If it follows the Pythagorean theorem, then we can say TSO is a right triangle. And if TSO is a right triangle, then TS is a tangent line. And there you go. Try the last one on your own and we'll be done with the lesson. Go ahead and try number 3 now. Here is try number 3. Now, let's determine whether a tangent line is shown. It has to follow the Pythagorean theorem. If it doesn't, then guess what? It's not a tangent line. Let's see. A squared plus b squared equals c squared. A is the shortest leg, which is 8 squared. B is the longer leg, which is 14 squared. And 16 is the supposed hypotenuse. 8 squared is 64. 14 times 14 is 196, excuse me. And 16 plus 16 is 256. Let's add up 64 and 196. What do we get? 260. Guess what? 260 and 256 are not equal. So guess what? Triangle DFO is not a right triangle. Therefore, if it's not a right triangle, DF is not a tangent line. And there you go. If you got that right, good for you. Now, good luck and move on to the assignment that I've assigned you. Have a good week, guys. I'll see you next week. Bye.